Okay, guys. So today I will show you how to prepare a normalized time series. So that usually when we do a time series, we prepare time series set, we have different variable. So the value can be different, like the unit for rainfall and temperature and wind speed. All the unit is different. So it's quite difficult to compare between this data set. So usually people will tackle this issue by using normalization. So they normalize the time series into from 0 to 1 value, and then after that you can easily compare between the time series. So I will share the screen first. I'll show you how it actually looks like. So I'll share the screen, put myself down here, and yeah, we want to prepare something. Oh, it's at the back actually. At the back here. So we want to prepare something like this. You see, this is the monthly mean value for precipitation, relative humidity, temperature, and wind speed. Four variable, and then we normalize the value from 0 to 1 in the y-axis. So this way we can easily compare the relationship between these variables. You can see here precipitation and relative humidity and also temperature have quite similar distribution, but for wind speed they have inverse distribution. So very easy to understand, right? If compare when we analyze the time series separately. So this is one of the way to compare the time series. So let me show you the output for this one. So this is the step for this tutorial. First, you need to load the necessary libraries and dataset with each ggplot2 and the player2, and then you load your input dataset, and then you convert the year and month into date format, and then we filter data for the years 2021 to 2023, and then we define normalization function to scale the data between 0 to 1, and then we group the data by month and compute mean values for temperature, precipitation, wind speed, and relative humidity into mean monthly value. And then we apply normalization for each variable, and then we reshape the dataset to long format for easier plotting. And then we use ggplot2 to create a line plot of the normalized time series with color coded by each variable. So first here you load the necessary libraries. We have ggplot2 and dplayer. So you run this one, and then you read your set working directory where you put your dataset. So I put my dataset study Excel file here. This is my dataset, so I put it in this working directory. You just copy your folder directory. Working directory is your folder directory, and then you just copy this one, paste, and then put it double here. This one must be double for each subfolder, and then you run this one. See, no problem. And then you read your CSV file, which is my study parameter ZS2 just now. So this is my data. So I read this CSV file. So my data set is arranged like this. This is one of the most important one. You must understand how you arrange your data. So I have year from 2021 until 2023 months, and then start with the variables. I have temperature, precipitation, wind speed, age, dust, biomass, SO4. So all of this variable is in different column. So now we convert that dataset that just now into that format. So we run this one, and then you can see if I view the dataset, now at the end of that dataset, we have at the end here date in this arrangement at the end. We create another date format here. So easy for this R to read the code. And then we filter data from 2021 to 2023. So this is the data that we want to calculate the mean actually. So you can filter the data first from 2021 to 2023. So it's more or equal to 2021. less or equal to 2023 year. We will filter the year. Now we create a function to normalize the data. So if we have function x, we normalize it with this equation. This is the equation to normalize the data. So x minus mean x, function x just now, uh, uh, missing data equal to 2, x max minus this, max minus mean over here. So this is a function to normalize your data set. So you create this function first, x function, and then we group that data set just now by month and normalize each of these variable. So we group by month, we group it by month, filter, group by month. We summarize because what we want is the mean of each variable. So this is from 2021 until 2023, right? So we want the mean value for each month only. So we calculate the mean for TAVG, and mean for precipitation, mean for wind speed, and mean for relative humidity. And then we mutate and normalize this each of these variable. Mutate and then we normalize. For the AVG mean just now, this one, the mean value, and then we normalize the precipitation mean and normalize the mean value of wind speed and normalize the mean value for relative humidity. And then we use vector month labels is from January until December, labels month's name. So we can group this one, okay, one. And then you can check the data by using the view function, and then you can look at that monthly here. Okay, now you see this is our normalized data set. So we have January until December, and this is the mean value for each of these variable that we selected, which is for temperature, precipitation, wind speed, and relative humidity. And another column start with the normalized value from 0 to 1. This is from 0 to 1 for each of that variable just now. Now, we reshape the data to long format. So this is reshape the data so that we easier for us to plot this to make plotting actually. That's why we do into a long format. So we use that monthly just now, select month and all of this normalized value and change it into long format by using pivot longer. So we use pivot longer for each of that normalized value just now, and then name it as names to variable, values to values. Okay, now we do a pivot longer. So actually, long format, it will look like this. You can view the data that long here. So this is the plotting will become easier once you do a pivot longer like this. So you see January is all the variable for each of these months for each of the variable, and then it start another February again, and then it's for each of that variable. So it will be easier to plot actually. And then and then we ensure month is treated as a factor with correct level. So we do this one, that long month, make sure that it is treated as factor with correct level, because sometimes it's used January as 1, 2, 3, 4, 5 until December, right? And what we want to do here is from January J until December, right? Sometimes if you not treated it as a factor, it will follow alphabetical order. So it's wrong. It must follow January until December, not following alphabetical order. So you run this one, and then you can see now it looks like, how does it look like? You see, from we want only factor as month. Okay, January, February, March, April until December. We want to make sure that it is by months. Now we define the color for plotting. So we have used colors. So the color will be define the color for temperature, for normalized temperature, normalized precipitation. So temperature just now I put it blue, precipitation, normalized precipitation as green, normalized wind speed as red, normalized relative humidity as purple. And then we create the plot. So we can create the plot now. Let's see. So we use ggplot. So ggplot that long this latest data set just now. AES x-axis is man, y is the value, and then the color will be based on the variable and the group based on the variable. So geometry size is equal to 1. Scale color, just now we want to do it manually, so that's why we define the color, because sometimes the color can become confusing. So the value will equal to color, this one, the color that we define. You can change the color up here, up to you. And then labs, so x label will be months, y will be normalized value, and the color will be the variable. Because we have the legend there, it will tell you what color is what variable. And then we have the title of the plot, normalized mean monthly time series of, this is very long, so I will make it short, of study variable. Study variable. Okay. Team minimal. Okay, now we run this plot. Let's see. We see. The color is correct. Everything is correct. So you will get this plot, normalized mean monthly time series. So easily you can put this data into your paper. You can just put into copy as bitmap just now, and then put it into your paper. You see this kind of plotting looks very good, better than when you prepare each of that variable individually. So the normalized value there is also, you calculate the normalized value, also very a good point there that you make assessment. You normalize it first, and then easily you can compare the relationship between the variable for each month. So you can see the relationship there. It's very nice. Relationship between precipitation, relative humidity, and temperature, they have similar relationship. So higher precipitation also means higher temperature, causing higher precipitation, causing higher relative humidity. But the inverse relationship is there. So doing higher precipitation, looks like the wind is become lower during that time. This is certain place, certain area happen like this. So I think that's all for today. Thank you for watching.